Hello students, welcome to Vista's Learning. This is Shruti, your chemistry tutor. We are in 11th standard in Vista's Learning where we provide the quality education for all, and we are in 11th standard S block elements, and this is our fourth lecturing class where we are studying about the first and second group of periodic table, which is referred to as S block elements. Here we are going ahead with the second group elements. We have already studied about the first group elements, their characters, their physical and chemical properties, and also important compounds of these metals, right? Now we are going ahead with the second group elements, where second group elements are called as alkaline earth metals, and we have from barium till radium. Barium, magnesium, calcium, strontium, beryllium, magnesium, calcium, strontium, barium, and radium. So all these are the group 2 elements, and we call, except this beryllium, all other elements or members of this group 2 elements as alkaline earth metals. So we have the point about that, except beryllium. B is the symbol for beryllium. So except beryllium, the second group elements are called as alkaline earth metals, and beryllium differs from all other elements. As we know, it is having a very small size, and due to that we have the difference with the properties of other elements. And also beryllium has the diagonal relationship with aluminium, where it has some of the properties which is having with the aluminium. Hence it is a bit differ from all other elements due to its smaller size. Now we'll get into the electronic configuration. Obviously we know electronic configuration is nothing but the arrangement of electrons, and these gives you the valence electrons, and which are responsible for chemical reactions. Hence if we go through this electronic configuration of each element, we can find out the outermost s orbital. If you see, beryllium will be having 2 shells. In the outermost shell, s orbital, you will be having 2 electrons. In magnesium we have 3, where 3s will have 2 electrons. In calcium 4s, likewise in strontium 5s. In barium we have 6s, likewise we have radium with 7s2. All these s orbitals will have 2 electrons, and hence they are in the second group. Hope you are understanding. As we have studied in the first group element, they all have only 1 electron in the outermost shell, but here for second group elements they have 2 electrons in the outermost shell, and also s orbit has only 1 single orbital. It don't have again subdivision like p or d or f orbitals, right? So it has only 1 orbital where 2 electrons can be fit into s orbital. So they are a bit stationary, or they are a bit stable than that of the first group elements, as they have 2 electrons in their orbit. Next we have atomic and ionic radii. What happens when the group 1 is here and group 2 is here? As we know, in the periodic properties we have studied, across the period size decreases, and down the group size increases. We know that, right? If you know that point, that is very good. Then you can easily answer this atomic and ionic radii point. So here if you see beryllium, magnesium and calcium, all these are down the group, right? As we know, first beryllium comes, and then magnesium, and then calcium. Their size is increasing as the number of electrons are increasing, and the cells also increases. So radius of them increases. Fine. But when we compare to group 1 to the group 2, what happens? Across the period size decreases due to effective nuclear charge. In the same orbit, more number of electrons are added and number of protons in the nucleus is more. Due to that, attraction will be increased and hence the radius will be decreased. The atomic and ionic radii of alkaline earth metals are smaller than that of the corresponding alkali metals. What are alkali metals? First group elements. That means if I take lithium and beryllium, lithium is the corresponding alkali metal of beryllium. So the size of lithium is larger than that of beryllium. Likewise, sodium and magnesium. Magnesium size is a bit smaller than that of sodium because this is an alkali metal where you have only one electron and the effective nuclear charge makes the magnesium to decrease its size. Due to the increased nuclear charge, this is what happening, the smaller size of the alkaline earth metals than that of alkali metals. Along the group, radii increases as we know as the number of electrons increases. Ionization enthalpy, we have studied this even with the group 1. What do you mean by ionization energy, students? Ionization enthalpy or ionization energy is the energy required to remove the outermost electron from an isolated gaseous atom. Now, if we take any one of the atom of this, we need to remove the electron, right? As we know, the size increases down the group. As the size increases, the nucleus cannot have the catch on the outermost orbit. So, down the group, it is very easy to remove the electrons. When it is easy, that means we need to give only less effort, less energy. So, ionization energy decreases down the group. As we saw even for group 1, similarly down the group for alkaline earth metals also ionization energy or ionization enthalpy decreases. Alkaline earth metals have low ionization enthalpy due to their larger size of the atoms. Here they are not comparing with the first group now. Generally in the periodic table they have larger size. So they will be having low ionization enthalpies compared to other groups, not compared to first group. Okay. Ionization enthalpy decreases down the group, as I said, increase in size. First ionization enthalpy. If we speak about this ionization enthalpy, that means removal of one electron from the outermost orbit. I have the orbit. This is the nucleus where one electron was present in first group element, that is alkali metals. So I can easily remove this electron by giving some energy, right? So this is the first ionization enthalpy for first group. And if I see inner core noble gas configuration will be there, that means 8 electrons will be there inside. So if I want to remove one electron from this, then the first electron I am removing, the second electron if I am removing, that is called as second ionization enthalpy. That means first ionization enthalpy is easier to remove from alkali metals. But second one is not so easy because it is having the noble gas configuration. It is already stable. It cannot give away one more electron. If that have to happen, we need to give more energy. But what happens with the alkaline earth metals? For the alkaline earth metals, what happens? Inner core we have 8 electrons. Okay, the nucleus will be here where it will be having 2 electrons. Now the first electron is been removed. Then we call that as first ionization enthalpy. And we have one more electron which is in the outermost shell. Then if we remove this, we get this atom into stable configuration, right? So the first one which I am removing will give you the first ionization enthalpy, whereas removal of second electron, the energy required to remove the second electron will give you the second ionization enthalpy. Hope you understand this. Now the first ionization enthalpy is higher than that of first group metals. Why it is like so? So first group will have 1 electron. We have 2 electrons in alkaline earth metals. What happens here is that if you remove 1 electron here, it is just a less electron energy we are giving. Here what happens, as I said, in S block we have paired electrons. It is very difficult to remove the paired electrons. As I said, in S block we have 2 electrons. If it is only 1, we can easily remove it. If any of your friends is alone, you can just call them easily. If they are having 2 friends, you cannot separate them easily, right? Similarly, even though if you want to do, you need to spend more effort on it. Similarly, here also, when you have the paired electrons, it is not so easy to remove them. So we have higher energy of enthalpy. The first enthalpy of energy will be more for alkaline earth metals than that of alkali metals. So what happens here, we can say the first group elements will have lesser first ionization enthalpy than that of the alkaline earth metals. And in the other way, we can say first ionization enthalpy of alkaline earth metals is higher than that of first group metals. And why it is so? Because of their small size. Generally, what happens with the second ionization enthalpy? As I said, generally to remove second electron, it will be very difficult. We have higher second ionization enthalpy for general compounds or atoms. But here what happens is that the second ionization enthalpy for alkaline earth metals is lesser. Why? Because you have 2 electrons. 1 electron you have already removed. When it is being paired, you removed 1 electron already by giving higher energy. Now it is only alone. So if you remove this, it will attain the octet structure or noble gas configuration. So this is more stable. So it will give you the second electron easily. So the second ionization enthalpy of alkaline earth metal or second group elements will be easier than that of the first one. Got it? So what is this point saying is that generally second ionization enthalpy will be higher than first ionization enthalpy. But for alkaline earth metals, it is lower. Second ionization enthalpy is lower than that of first ionization enthalpy. Now we'll go with the hydration enthalpies. What do you mean by hydration enthalpies? We also call it as solvation, right? So when the ions are added to the water, they dissolve in it, right? So we have hydration enthalpy is the amount of energy released when 1 mole of an ion is dissolved in large quantity of water. That is called as hydration enthalpy. So down the group, what happens? Size increases. As size increases, hydration enthalpy decreases. Means it cannot attract the water molecules. So what happens? Hydration enthalpy decreases. We can see beryllium to barium. We have beryllium with a higher hydration energy or enthalpy than that of barium. Hydration enthalpy of alkaline earth metal ions are larger than that of alkali metals. Why it is larger? As we know, the size will be smaller. Compounds of alkaline earth metals are more extensively having hydrated compounds. For example, magnesium, if I take magnesium chloride, as we saw yesterday, what happens? We have magnesium chloride with octa aqua or octa hydrated. 8 water molecules will be with the magnesium chloride. Likewise, calcium sulfate, that will also have 5 molecules or 8 or 6 molecules of water added with it. So they have the hydrated salts than that of alkali metals. We can see the same thing they have given here. Magnesium and calcium chlorides will have hexahydrated. That means calcium chloride dot 6 water molecules. Hexa means 6. So hexahydrated. While we know that we have studied about sodium and potassium. They don't form the hydrated salts. Next, we are going ahead with physical properties of second group elements. As we know, they are silvery in nature, they are lustrous. What do you mean by the lustrous? We have studied in our high school, 9th and 10th standard, what do you mean by lustrous property, malleability, ductility? These are the properties of metals, right? So lustrous means to shine. When it is been given with the light energy, it reflects the light energy, it shines. So that shiny property is called as lustrous. And as we know, they are soft metals. Why they are soft metals? Because they have less dense and they have the softness than that of other elements, but they are not soft than that of first group elements. They are soft but not softer than that of alkali metals. They are harder than alkali metals. See, first group, when you are studying, you are just studying their properties, but when you are studying with the second group, you have to take the comparison with the first group and then remember them. Beryllium and magnesium appear to be grayish in color. What about the melting and boiling point? Melting and boiling point of these metals are higher as corresponding to that of alkali metals due to the smaller size. As small size, the attraction will be more. So what happens? Melting point and boiling point will be obviously more. They are strongly electropositive. Yes, that is true. They will be having +2 charge. So they are positively charged particles, or they are electropositive, and hence you can say that since they have low ionization enthalpies, they can easily form the positively charged particle. And the electropositivity increases as the size increases. How does the size varies? Down the group, size varies. As size varies, the ionization energy or enthalpy will also lowers, and hence the more electropositive the element will be. Next, we have some of the main things as we saw in the first group elements test, the flame test. They will give you the variant flames, right? Similarly, in second group also, strontium, barium, calcium, these give the significant or characteristic flames when held with the flame. What happens exactly is that when the electron is in ground state, it jumps to the higher energy level by attracting absorbing some energy, and when they are coming back, the amount of energy is been given out, and these are in visible region. These are in visible region. When these are in visible region of different wavelengths, then we can easily identify their colors. So for strontium, we have crimson red color. For barium, it is apple green color. You can see this green color. This green color is due to barium, and we have this brick red color for calcium. So there is a difference between brick red and crimson red. Crimson red is very reddish in color, whereas brick red is like a orange type. Okay. So these electrons, as we know, electrons in beryllium and magnesium, they are very too closely present in the atom. So if I take beryllium, it has only 2 orbits, so the outermost electrons are very close to beryllium. Similarly to magnesium, it has only 3 orbits. So what happens? They cannot easily remove, and hence they will not impart any characteristic flame or color when you subjected it to flame. So these in the sense alkaline earth metals will have high electrical and thermal conductivity, which gives you the property of metals. As all these are metals, we can say they give you the property of conductivities. Next, we are going ahead with chemical properties. What are the main chemical properties we are studying? Whenever we speak about chemical properties, reaction with air, water, halogens, hydrogen. These are the main things. Same thing we are going ahead now. Alkaline earth metals are less reactive than alkali metals. So that means first group are the most reactive elements compared to that of other elements, and these alkaline earth metals are also reactive, but they are less reactive than alkaline earth metals are less reactive than alkali metals. Down the period, what happens? Reactivity increases. That means in the same group, down the group, as size increases, the reactivity increases. So we are going ahead with reactivity towards air and water. So beryllium and magnesium kinetically inert to oxygen and water molecule as they form oxide films on their surface. They directly form the oxide surface on the surface, oxides of the magnesium and beryllium, but they are not too chemically or kinetically inert. What do you mean by kinetical? They are not vigorous. So beryllium burns on ignition in air to give beryllium oxide and beryllium nitride. Even magnesium is more electropositive, as we know. It burns with dazzling brilliancy, means dazzling flame. You might have done this experiment in your high school too. Magnesium burns with dazzling brilliance flame in air to give magnesium oxide and magnesium nitride. Calcium, strontium, barium are readily reactive towards air and forms oxides and nitrides. Next, we have the reactivity towards halogens. So even these second group elements also react with halogens. When you see this thermal decomposition of ammonium beryllium fluoride, because the fluoride is not easily formed, it is always highly reactive and it will be in the complex, right? So how to form the beryllium fluorides? We can prepare the beryllium fluoride by thermal decomposition of this complex. Next, generally other metals react with halogens to give other metals of the second group elements react with halogen to give the metal halides. As I say, the calcium plus chlorine. If I take an example of this, I'll get calcium chloride as a molecule. So you can take fluorine, chlorine, bromine, iodine, anything. As we said, beryllium fluoride is not easily formed with this method. Instead, we can form it by thermal decomposition because fluorine is very highly reactive element. Beryllium chloride is made from the oxides. Even beryllium chlorides are formed from its oxides. You can see this beryllium oxide in presence of carbon and chloride. Then we can get the beryllium chloride with carbon monoxide, which has been given out at 600 to 800 Kelvin. Next, reactivity towards hydrogen. How does this second group elements react towards hydrogen? As we see, beryllium is a smaller size, except this all others will form the hydrides when reacted with hydrogen gas. And beryllium hydride, how to form it? It is formed by reacting beryllium chloride with lithium aluminium hydride, LiAlH4. So lithium aluminium hydride reacts with beryllium chloride to give beryllium hydride. Directly beryllium will not react with hydrogen gas. Beryllium chloride reacts with lithium aluminium hydride to give beryllium hydride with lithium chloride and aluminium chloride. Next, reactivity towards acids. Alkaline earth metals readily react with acid liberating hydrogen gas. We have studied this in hydrogen chapter. Do you remember that? How to produce the hydrogen or dihydrogen using acids? When you add the metals to them, either alkali metals or alkaline earth metals, they release the hydrogen gas, and this is the chemical properties of second group elements where metals reacts with acid. Here we have taken hydrochloric acid. It gives you metallic salt with hydrogen which has been evolved or liberated out. Next, property or chemical properties, reducing nature. They reduce, right? What do you mean by reduction? Reduction means addition of electrons. Oxidation means removal of electrons. So these have the reducing nature, means they reduce the other elements by giving the electron, such that other substances will gain the electron and become reduced. So what about the reducing nature of these alkaline earth metals? They are strong reducing agents, as they can lose electrons easily, and they have high negative values of their reduction potentials. If they have high negative values, that means large amount of energy is released, so that they become stable. Alkaline earth metals reducing power is less than that of alkaline metals. Obviously yes, because if you compare the alkali metals and alkaline earth metals, alkali metals can easily give the electrons. As we see, first ionization enthalpy of alkaline earth metals is more than that if I take first group and second group elements. The first ionization energy is high for second group elements. That means the first group elements can easily remove the electrons from their orbit. So it is having more reducing power than the second group elements. You have to just connect with each point such that you can remember each and every chemical properties of the first group and second group elements. Beryllium, this is a symbol of beryllium. Beryllium has less reducing agent, or it is having less reducing power than other elements of the same group. Why? Because it is having the lesser or smaller size. Beryllium shows reducing power due to it is also having a bit of reducing power. It is not at all reducing, we cannot say that. It has a little bit of reducing power. Why it is? Because of its larger hydration energy associated with that smaller ion of Be+2. Even though it is having less reducing power, why it is having that reducing power? Because it has the large hydration energy, and also it have large atomization enthalpy. Hope you understand this, students. So next we'll go into the solutions in liquid ammonia. As we see, even the reaction with ammonia, we can say this. So all these metals, group 2 metals, if we say, they can dissolve in liquid ammonia. When they dissolve in liquid ammonia, they give you the complex which is blue-black solution. That forms the complex which gives you the deep blue-black solution forming ammoniate ions. So you can see the general formula here. M is a metal which reacts with ammonia to give you the compound. It is a coordinate complex where you get the electron combined with this complex, again ammonia. So you can see this is how it can be formed. The metal will be, central metal ion will be in the center, and all the ammonium ions will be connected with the central metal atom, and you have the charge for this coordinate sphere. So that is what we have written here. You can get this is +2. So this is what we get, the complex when the metal is been reacted with liquid ammonia. So what are the uses of all these first and second group elements? First group elements we have studied. Now we are speaking about second group elements and what are their uses. These uses are very much important. As we see alloys, so in most of the alloys we have this beryllium and magnesium. So copper beryllium ions are used in preparation of high strength springs. If you see the springs, in that spring will be having beryllium with copper as an alloy. And we also have metallic beryllium which is used in the windows of X-ray tubes. Magnesium alloys with aluminum, zinc, manganese and tin. They can form a alloy with these things. Magnesium alloys, aluminum alloy being light mass, will be used in aircrafts. We know that aluminium will be used in aircraft. Not only aluminium, the alloy with this, the alloy, it is a alloy which is been used. With that we also use magnesium. Magnesium is also used in flash powders, bulbs, incendiary bombs, and also in signals. So it is, you can see magnesium hydroxide is a compound, important compound of magnesium, which is used as antacid. If we get gastritis, what does the doctor prescribe you? The tonic, like, right, which will be pinkish in color. That is nothing but magnesium hydroxide. So the stomach produces hydrochloric acid for dissolving the substances whatever we eat. If it is high in generation, or if it is been synthesized more in the stomach, to reduce that we are taking this base. Magnesium hydroxide is a base which neutralizes the production of hydrochloric acid in the stomach, and hence we call it as antacid. Antacid means acid, anti-acid, opposite to that of acid. Whatever acid is been produced, that will be nullified by adding this magnesium hydroxide. Magnesium carbonate is used in the toothpaste. We all brush daily, right? So there we have this magnesium carbonate which is added to the toothpaste. Calcium is also used in the extraction of metals, and if you are taking the metals, if you come with the metallurgies, what happens? They all are made up of oxides. So when you want to remove the metals from oxides, you can use this calcium as a reducing agent if they are not reducing with the carbon. If it is very difficult to remove with the carbon, then you can use this calcium. Calcium and barium metals are used to remove air from vacuum tubes. They release high energy when reacted with oxygen and nitrogen, and that energy will be utilized to remove the air from the vacuum tubes. And finally, radium salts are used in radiotherapy. What do you mean by radiotherapy? Here, for many things we are using this radiotherapy, right? Mainly for treating the cancer, we are using this radium salts. Hope you enjoyed this class, students. This is Vista's Learning. As we always say, we provide you the quality education for all. If you have any of the doubts regarding our videos or the subject, you can just get back to us. We are happy to reply you back. Thanks for watching Vista's Learning. ಮಾಡಿ